Welcome back to EduHut Academia, the Education for a Better Future platform. We are resuming our physics course, The World of Physics, lecture number 16 about particle physics. Particle physics is defined as the high energy physics that travels into the deepest layers of matter to explore the fundamental particles and forces that make up everything around us. It goes beyond the building blocks we typically learn about in chemistry, like atoms or molecules. It ventures into the kingdom of the truly fundamental and smallest subatomic particles. Now, who are the fundamental players in this game of particle physics? They can be split into two or classified into two main categories. Number one, the fermions, which are the matter particles. And according to the Standard Model, there are three generations of fermions. The first generation, which makes up ordinary matter, includes the electrons, the up quarks, and the down quarks. Now, quarks combine to form composite particles like protons and neutrons that we know already exist inside the nucleus of an atom. Other interesting fermions include therons and muons. Number two, in the fundamental players, the bosons. These are the force-carrying particles. They are not the matter. They are the messengers that mediate the fundamental interactions between fermions. Fermions, which are the matter particles. The photon, for instance, is the carrier of the electromagnetic force, while the W and Z bosons carry the weak nuclear force. The gluon mediates the strong nuclear force which binds quarks together. Now, the Standard Model of particle physics is the current ruling theory in particle physics. It explains three of the four fundamental forces in nature: the electromagnetic, the weak nuclear, and the strong nuclear. And it also explains how these forces arise from the exchange of boson between fermions. You might wonder, how come we said there are four fundamental forces, yet we only identify three? Where is the fourth one? The fourth fundamental force is the gravitational force. But this gravitational force is relatively weak compared to the other three. It's weaker when it comes to fundamental forces. Now, what's the story of those accelerators? Now, particle physicists use powerful machines called particle accelerators to investigate the properties and interactions of the fundamental particles. These accelerators smash particles together at incredibly high energies, recreating the conditions that existed just after the Big Bang. By studying the debris from these collisions, scientists can unravel the nature of the fundamental particles and the forces that bind them. So scientists try to understand or to find out what really happened at the Big Bang. Some of the most famous particle accelerators include the Large Hadron Collider, which is located at CERN in Europe. Thank you very much for listening, and I look forward to meeting you in the coming lecture.